Hello everyone, welcome to the second lesson of SuperMap GIS Contest Training. I'm Mei Hui from SuperMap Software Limited Company. In last class, we have appreciated several excellent works from previous SuperMap GIS contests. For all these works, beautiful and clear maps are of great importance. The design of your map partially decides judges' first impression on your work. So today, we are going to focus on the theoretical cartography and map-making methods. And I hope that after this class, all of you are able to present spatial data in a professional and exquisite map. Today's lesson can be divided into 4 parts. First of all, we'll have a quick introduction on basic map knowledge, including principles of map design and general procedures of map production. Secondly, before presenting, we are supposed to do the data preparation, which means we have to process data and analyze data based on certain application cases. Then, we are going to design maps in SuperMap Desktop X to present key information produced in data preparation process. We'll assign proper symbols for different layers and create necessary labels to make the map concise and easy to read. Finally, an informative representation of a GIS project should consist of both map body and complementary elements. Here, I'll guide you on basic operations in layout design. Now, let's start with discussions on basic map knowledge. Map always plays an important role in human life and history. Since ancient times, people in various cultures have drawn maps of their land and the ocean by hand. Although they are not as accurate as maps we use today, traditional maps are essential tools in social activities. And it's the same nowadays. Most commonly used applications of GIS, like Google Maps and Uber, use digital maps to show basic information of an area, including streets, rivers, buildings, these kind of simple objects. And also routes they plan for users are presented on the map as well. Here, maps work as the base and representation of spatial information in sophisticated geographic information system, while we as GIS experts also need to create and design our own maps to demonstrate our work. Here are some examples of modern maps. Different from ancient maps, we have more diverse forms for visualization. They may be more vivid, dynamic, even three-dimensional. Now, you should have no doubts on the significance of maps in the communication and decision-making process in varied fields. In every GIS project, we have done a lot of work in data collection, editing, and spatial analysis. And the majority of these efforts is finally presented to audience in the form of maps. So, the design of your map partially decides others' first impression on what you have achieved in a project. And here are some helpful suggestions on what to take into consideration in map making. We recommend to keep at least these 6 principles in mind when designing and making your maps. First principle is purpose. Are you going to show general information of an area in one map? Or do you want to highlight specific kind of feature in one area? The way of map design should be varied based on your purpose. For general information, you should design a reference map. And to highlight something, you should make a thematical map. Then, it's the scale of area to be mapped. If you are using small scale to cover large area, it's better to drop some detailed information and make sure the symbols will not cluster together. When using large scale to focus on a small area, you can keep more details and there are more choices on symbology. And the choice of symbology is also important. Based on a full understanding of the data, you want to choose the best symbol that emphasizes feature characteristics. For the overall appearance of your map, do not forget about its visual aesthetics. You can improve it by adjusting contrast, legibility, and organization of layers and elements. Audience here means when choosing information expressed in the map, you need to consider whether it can be easily understood by the majority of readers, or if readers have enough time and knowledge to comprehend abundant information. For the same project, the map presented to the public should be much more concise to that used in discussion with experts. Finally, the use environment and display media could affect your design as well. If it's printed on paper, the size of paper and colors of ink should be taken into consideration, while you don't have to worry about them when making digital maps. Keep these principles in mind, and we can start the procedure of map making. First step is to prepare data for visualization. Next step is to choose proper style to symbolize spatial data. Third step is to create labels for the map which convey more information. Final step is to decorate map with other necessary complements. After discussing about basic map knowledge, now come to the second part of this lesson, data preparation. To prepare spatial data, the first thing is to integrate multi-source data in SuperMap software. That means to transform multi-source data into SuperMap datasets. After that, we can use diverse tools provided in SuperMap software to process spatial data, like graphic editing, attribute editing, coordinate transferring, vector processing, raster processing, etc. Usually, only processing data can't help us to dig the deep or potential laws which are hidden in spatial data. So, we are supposed to use data analysis tools to analyze the patterns behind the data until analyzing results meets the mapping requirements, which can be visualized directly. Okay, from now on, I'm going to take this case as an example. During introducing the case, I also will present the operation methods of data processing and data analyzing. We also suggest you to try other tools which are not presented here after class. This case will focus on southeast region of Brazil. Brazil is the largest country in South America. However, natural hazards are frequent in Brazil, and landslides are considered one of the most common hazards in the country. Such hazards threaten the life of people living in mountainous areas and might cause huge economic loss. So, it is necessary to evacuate people from area of high and relative high susceptibility of landslide hazards. In this case, we'll evacuate the susceptibility of landslide hazards in southeast region of Brazil, and the final results could be useful in hazard management and prevention. Susceptibility of landslides is influenced by varied factors like terrain, soil type, rainfall, vegetation coverage, and etc. Here, we are going to evaluate 4 factors related to landslides in the study area respectively. They are slope, annual precipitation, land cover type, and proximity of rivers. If the slope is more than 15 degrees, or the annual precipitation is more than 1,500 millimeters, or the land cover type is deforestation and shrub area, or the distance to rivers is less than 2,500 meters, we consider that the landslide hazards occur more frequently in this region. Of course, in more sophisticated research, more factors should be taken into consideration, and evaluation criteria and weights could be further discussed. All datasets are stored in UDBX data source called Brazil Southeast. The first defines the boundaries of the states in Southeast region. Then we have the weather station points, whose attribute table contains annual precipitation information for each station. And rivers are divided into 2 types, line features and polygon features, based on their width. DM and land cover are stored in raster format. Among the 4 factors of landslides, we already know the exact information on land cover, so the task for this part is to extract slope, precipitation, and river buffer of the study area. First of all, we can use slope analysis tool to extract slope from DM raster. Slope is the gradient of a unit of terrain. The larger the slope value is, the steeper the terrain is. And the same, the smaller the slope value is, the fatter the terrain is. Before we begin this exercise, let's look at the data we have prepared. First, there is a UDBX data source named Brazil Southeast. And we also have 2 documents which will give some reference when we do this exercise. First, we need to open SuperMap Desktop X software and drag this data source to Workspace Manager. Then we can open it. Under this data source, we can see there are 6 datasets. The first 2 are DM and land cover raster datasets, and Brazil Southeast is a region dataset which contains the boundaries of Southeast Brazil. And water resource is divided to 2 datasets. This is the region dataset for water, and this is the line dataset for water. There is also a point dataset which contains the weather station points. Now, let's start from the first tool, slope analysis. This tool is in Spatial Analysis tab. And in raster analysis group, we can find the surface analysis functions. In its drop-down list, we can find slope analysis function. Click on it and open this slope analysis panel. In this panel, we have to choose the dataset as DM Southeast and change the result dataset name as slope. Then we click this button to run this function. Wait for a few seconds, we can get the slope results. Double-click on it, then we can open it in a new map window. In this map window, we can see the slope results for this DM raster dataset. This is the first step to do the analysis. Here are the comparison of DM raster and slope raster. Then we come to the second factor, precipitation. This factor needs 3 steps to analyze. First, we can use interpolation tool to estimate precipitation of the region by sample points with known values. Second, we should clip interpolated precipitation raster to boundaries of southeast region. Last, to make the result clearer, we can extract ISO regions according to the designed intervals. Now, let's start from the first step, interpolation analysis. Back to SuperMap Desktop X software, we need to find the interpolation analysis function. It's also in Spatial Analysis tab. And in Raster Analysis group, we can find the interpolation analysis. Here, we choose Spline as the interpolation method and open this panel. In this panel, we need to choose the source dataset as Weather Station Southeast and set the analysis fields to annual precipitation because this is what we are interested in. And then, for result data, we need to set the resolution to 0.00833 and set the null value to minus 99999. Besides these parameters, we also need to set its analysis environment. Here, set the result bounds to use specific dataset bounds and change the dataset to Brazil Southeast. For default cell sets, we also need to change it to use specified dataset resolution, and the dataset remains DM Southeast. That's all about the settings. Then we run this function. After a few seconds, we can get the results. Here, this is the interpolation results for weather station points dataset. As we can see, the result of interpolation is in a rectangle region. That's not as same as our research region. So we have to clip this raster to boundaries of southeast region. To clip this raster, first we have to drag Brazil Southeast region dataset into this map window and change to Maps tab. In Operation Group, we can find the Map Clip function. Here, we clip the map by the selected objects, so we choose this one. And select all the regions in this map. After selecting, right-click on it. Then we can get this Map Click panel. In this panel, we have to remove Brazil region dataset. We only need to clip this raster. And here, we can change the result dataset name as precipitation. And click OK. Then we will get the precipitation raster of the Southeast Brazil region. Last, to make the results clearer, we can extract ISO regions according to the designed intervals by using Extract Given ISO Regions tool. This tool can also be found in Spatial Analysis tab, and in Raster Analysis group, we can find the Surface Analysis functions. In its drop-down list, here is the Extract Given ISO Regions function. Click on it and open this panel. In this panel, we can click this button to add batches. Here, set the start value to 0 and set the increment to 500. Because we want to extract ISO regions every 500 meters. And here, click OK. Then we scroll down. For parameter settings, we need to set the resemble coefficient to 3 and choose the beta spline smoothness coefficient. At last, set the result dataset's name as precipitation isoregion. After all these settings, we run this function. Then we double-click on this precipitation isoregion dataset to see what it's like. And then open the attributes table, we can see the d max z value and d min z value. The intervals are 500 meters, which is the same as we set just now. The last factor we are going to analyze is the distance to rivers. If distance to the nearest river is less than 2,500 meters, we consider that the landslide hazard occurs more frequently. Here, we suggest you to use buffer analysis tools to analyze which places are easier to be affected by rivers. River datasets are different from datasets we have analyzed before. They are vector datasets. So, the buffer analysis tools are in Spatial Analysis tab and in Vector Analysis group. Here we can find buffer zone and click this buffer zone function to open this panel. For buffer datasets, we change it to water P southeast and set the buffer radius to 2,500 meters. In parameter settings, we click Union Buffer and we don't need to display it on map. Last, to change the result dataset name as Water P Buffer. Then click OK to do the buffer analysis. And then we use the same method to do buffer analysis for water line. Here, open this buffer zone function again, and this time change data type to line and the dataset to water L southeast. Set the buffer radius to 2,500 meters. Click Union Buffer and set the result dataset name as water L buffer. Then click OK. Here we can see this water L buffer is shown in the map. We can also drag water P buffer to this map window to see these two water buffers. And that's all about the procedures of data processing and data analysis. And now, let's start the third part of today's lesson, layer style. We are going to learn how to use proper symbols to symbolize features and create labels on the map. In SuperMap Desktop X software, we provide 3 kinds of sources for users to symbolize points, lines, and regions. They are all stored in Resources node of Workspace Manager, here, named Marker Symbol Library, Line Symbol Library, and Fill Symbol Library. When we open one of them, we can see all the symbols of the same kind for this workspace, like these 3 pictures shown on the right. If symbols provided for us in symbol libraries can't meet the mapping requirements, we can also create our own symbols or edit some already existed symbols. If you get some other symbols from other websites or other organizations, you can also import symbols to Symbol Library. And for the same, if you want to share your symbols to others, you can export your symbol library and send the document to your friend so that he can import symbol library document to get your symbols. Now back to SuperMap Desktop X software. Here we have done all the data preparation work, so we can close all the windows. And in Workspace Manager, we can find the Resources node. In the Resources node, we can see these three symbol libraries. Take Marker Symbol Library as an example. Double-click on it, and then we can open this marker symbol selector. In the middle window, we can see the symbols for points. Scroll down, we can see all the symbols. If you find the symbols here can't meet the mapping requirements, you can create your own symbol. Here, we can click this New 2D Symbol button and open this Marker Symbol Editor panel. In this panel, we can use these tools to draw a symbol. After drawing the symbol, you can also set the symbol number and the name and save this symbol. Once you save this symbol, you can see the symbol in this area. And if we have already get some symbols from other websites or other organizations, we can also import them. From the File tab, here you can see we can import Marker Symbol Library, Marker Symbol, Raster Symbol, SVG Symbol, TrueType Font, and AutoCAD Font to this Marker Symbol Library. They are all the formats we have supported. And if you want to export symbol libraries to your friend, you can click here, Export, then export this Marker Symbol Library document, and send this document to your friend. Then he can open it and get your symbols. This is for Marker Symbol Library, and it's the same for Line Symbol Library. For line symbol, we support to import line symbol library and line symbol. And for fill symbol library, we support to import fill symbol library, symbol file, and picture. Now, let's talk about how to symbolize feature by using symbols we have seen just now. There are two methods for us to symbolize features. The first method is to use the uniform style to symbolize one layer. That means one layer only has one style. There is no differences between features in one dataset. And the second method is to use the thematic map to symbolize features. Usually, we prefer to show the properties or attributes by using different colors or different symbols to describe different features. In that way, we can create thematic maps to help us symbolize features. First, for the uniform layer style, we have two methods to do that. The first method is under the Style tab, we can see the marker style, line style, fill style, text style groups. In these groups, we can change the color, the size, width, foreground, transparency, this kind of style for the features. And the second method is to select a layer in this Layer Manager and right-click on this layer. Then we can find the Layer Style option. Click on it and open the Layer Style panel. In this panel, we can choose the symbol to symbolize the feature, and we can also set the foreground, background, transparency, and color, these kind of parameters. And second, for thematic layer, we also have two methods to do this. The first method is in the Thematic Map tab. In this tab, we can see the unique value, ranges, label, statistic, these kind of groups. In these groups, we can create thematic layers for different datasets. And the second method is to select a layer in the Layer Manager and right-click on it to choose Create Schematic Map Layer and open this Create Map panel. In this panel, we can choose the schematic layers of different types. From what I have introduced above, we know that in SuperMap Desktop X software, we provide different kinds of schematic maps. Unique value maps divide the objects by the same property fields into a class and set a render style for each class. Unique value maps contribute the data type, but they can't express the quantifying information. So, the maps with categorical attributes usually use it, such as the soil use type, land use type, administrative map, etc. And the second kind of schematic map is the ranges map. Ranges map displays data of a specific attribute according to ranges you set. These ranges are shaded with different colors, patterns, line styles, or symbols in certain ranging methods. In a ranges map, the schematic values are divided into several ranges according to a certain ranging method. A ranges map must be based on a semantical variable of a numerical type. Ranges maps are usually used to represent volume or degree characteristics of continuously distributed phenomena, such as distribution of precipitation and distribution of soil erosion rate. Label maps are used to annotate point, line, or region objects on the map with text or numbers. For example, you can create a label map for a river dataset to annotate the rivers with their names or lengths on the map. The graph map draws charts for each element or reflects the corresponding semantic value. Unlike other semantic maps, the graph maps have their own unique features. Graph maps are usually used to show demographic information. For example, GDP and population of each state. More than one semantic variable can be displayed in each graph. You can also compare these semantic variables across the entire map. The graduated symbol map uses symbols with different shapes, colors, and sizes to represent the quantity and quality characteristics of each object, which is independent and displayed in an overall concept. Normally, the shape, color, and size of the symbols reflect the specific attributes of the objects. The shape and color represent the quality characteristic, while the size of the symbol means the quantity feature. The graduated symbols map is mainly used to the map with quantity features, such as classification of the food production in different regions, GDP, population, etc. Grid unique values map categorizes pixels with the same attribute value into one class. Different classes are represented with different colors. Grid ranges map subdivides the value into a number of ranges. Pixels with values within the same range are assigned the same color. Apart from symbology expression, labels are also necessary for different kinds of maps, because labels communicate attributes or ancillary information to the map user. By reading the labels on the map, users usually can get more information. And labels must be placed proximal to their symbols, so they are directly and readily associated with the features they describe. To create labels on the map, we have two methods. The first method is to create a text dataset and add the text into these text datasets. This kind of method has some advantages. For each label, they may have independent content and independent position and independent label style. That means every label is unique. And this method also has one disadvantage. We only can create labels on the map one by one, so it costs much time if we have a large number of labels to add. And the second method is to create a semantic label layer. For this kind of method, it also has some advantages. If we use this method to add labels on the map, we can add a large number of labels at one time. And the contents of the labels will be automatic updated according to the attributes. It also has some disadvantages. For instance, all the labels in this layer may have the uniform style. That means we can't change one label to a unique style. And the large number of labels may cause possible overlaps. Then let's see how to create labels on the map. First, for the text datasets, we have to create a new text dataset at first, and then add these datasets to current map and edit the text in this layer. And at last, save the edits. If we want to create a semantic label layer, we have to choose the layer and right-click on it. Then to create a label semantic map. We provide three kinds of label maps: uniform, unique, and range. For users, you can choose one according to your mapping requirements. After creating the labels, we can set the styles of the labels. Those are the theory of map making. From now on, we are going to continue our work. In this exercise, we'll choose appropriate styles to present full analysis results of landslide susceptibility assessment in southeast region of Brazil. All the data are stored in a data source named Brazil Southeast. The datasets listed below are the data we are going to present, including the weather station points, the land cover data, and the state boundaries, slope analysis results, precipitation ISO regions, and the buffers to water L and water P. For all the maps, we have to create the boundary layer and the semantic label layer. First, let's see the boundary layer. Now let's back to SuperMap Desktop X software. And here, in Workspace Manager, double-click on Brazil Southeast Region dataset and add this dataset into a new map window. Then we can see these regions. In Layer Manager, choose this layer and right-click on it, and to choose Layer Style to open this Layer Style panel. In this panel, we can select a symbol to symbolize all these regions. Here we choose System 1, because this symbol has no filling color. And then we change the line width to 0.5 millimeters to make it wider. And this is the boundary layer. Then we have to create a semantic label layer. for boundary layer. So we come to the layer manager and choose this layer. Right-click on it and create thematic map. In this Create Map panel, we choose Label Uniform Map and Default Style, then click OK. We can see 4 labels are added to this map. But the labels are not what we want. So we can come to Thematic Mapping panel and change the expression to Name 1. Name 1 are the names for every stage of this area. This is exactly what we want. And then we come to the overlap setting. Choose the No Overlap mode to avoid at 8 directions. And change to Style tab. In this tab, we can set the font of the labels. Change it to Canberra. And then add the outlines to the labels and set the outline color to white. And to make these outlines wider, change it to 3 pixels. At last, click Bound. OK, and this is the label layer. Then we need to create the first map, Slope Map. For this map, it consists of 3 layers: the label layer, the boundary layer, and the slope layer. So we drag this slope dataset into the current map window and drag this layer to the bottom to change the order of the layers. This is the slope map. Now we have finished this slope map, so right-click in the map window and Save Map. Set the map name to Slope Map. And click OK. Then we can see under Maps node there is a new map, Slope Map. This is the first map we create. Then let's see the second map. The second map is the water map. For the water map, we also need the label layer and the boundary layer. Besides, we need 2 water buffers layer. We have to add these 2 water buffers datasets to this map window and change the styles of these layers. For this slope map, we can remove the slope layer and add the water P buffer and water L buffer dataset into current map window. And select these 2 layers in Layer Manager, right-click on it, and choose Layer Style. In Layer Style panel, we can change the foreground color to light blue and change the line color to dark blue. Drag these 2 layers to the bottom of the map. This is the water map. Now right-click in the map window and save as map. Set the map name to water map. And click OK. This is the second map we create. Then come to the third map. Third map is a precipitation map. For this map, we have to create several layers. The first layer is the weather station layer. First, we need to remove these 2 water layers and add the weather station points dataset into current map window. And choose this System 0 symbol to symbolize the point features. Scroll down to change the color to gray. This is the weather station layer. And the second layer is the weather station label layer. That means we have to create a label uniform map for weather station layer. Select Weather Station layer in Layer Manager and right-click on it. Create Schematic Map. Choose Label Uniform Map and Default Style. Click OK. Then we can see there are a lot of labels in this map, but they are not what we want, so we change to Properties and select Annual Precipitation as the expression. Besides, we also need to change to Style tab. In this tab, we can change the alignment to middle bottom and set the font size to 8, make it smaller. This is the weather station label layer. And the third layer is ISO region schematic layer. For this layer, we have to set the schematic styles according to the intervals. In Workspace Manager, drag Precipitation ISO region dataset into current map window and create a schematic map. Here we choose Ranges Map, Default Style, and click OK. Then we can click this I button to make this layer invisible. Then for this schematic layer, we can set its properties. First, to change a color scheme to ZQ Precipitation 3. And then we can set the ranges. For the first range, the biggest number is 500. And the second range is 1000. The third range is 1500. The fourth range is 2000. Okay, that's all about the settings of the ranges. Then we can see the new style for precipitation schematic layer. Then we have to change the orders of the layers. First, we drag these two label layers to the top. And then we drag these two precipitation layers to the bottom. This is the precipitation map. Right-click in the map window and Save as Map, and set the map name to Precipitation Map. And click OK. And the last map we are going to create is Land Cover Map. For Land Cover Map, we have to create a schematic map for land cover raster. First, remove the layers related to Precipitation Map. And add Land Cover Raster to current map window. This is the default style. Now let's create a schematic map and choose Grid Unique Value Map, default style, and click OK. And to make the original layer invisible. In Schematic Mapping panel, we can see the style and caption for different values. And here we provide a document of land cover legend. Open it, we can see the legend of land cover values. Then we need to put this document in the left and put our SuperMap Desktop X software on the right. After preparation, now we can set the style and the caption for each value. First, for 1, its caption is tree cover, broad-leaved, evergreen. We can copy this title to the table. And then double-click on this rectangle and pick this color as the style. That's the setting for value 1. And for 2, it's the same. We can copy the title and set the color. Then we can use the same method to complete this table. And now we have done all the works. And the last step is to drag these land cover layers to the bottom. And this is the land cover map. We can right-click in the map window and save as map, and set the name to land cover map. And click OK. Then we can see the land cover map under the Maps node. These are the 4 maps we have created in this class. Finally, we come to the last part of this lesson, layouts and elements. It's about how to properly organize our layers in a balanced layout with necessary elements, so that readers can get the key information instantly. Here are some examples of well-designed map layouts. From these 2 layouts, you can see at least we should have a title for our map, so that readers can directly know the theme of our map. And then the main body must be the map, which is like what we create in last exercise. Besides, legend, north arrow, scale are also necessary elements for a map. To sum up, layout elements should include title, map body, legend, direction indicator, scale, author. These are necessary elements for a professional layout. Apart from these elements, if you want to enrich your layout, you can also add overview map, graph, or other elements to your layout. And here are the layout design steps. First, we have to create and save the map, and then to new layout, and add map body to this layout, and choose a map to show in this map body. After designing the map, we also need to add some other elements into the map, like title, legend, direction indicator, scale, and so on. And last, we can save this layout and export this layout. Let's come back to this case. In this exercise, the main goal is to create a layout for precipitation map, which is already prepared in last exercise. While designing the layout, remember to add at least 6 elements in it, including map body, title, legend, scale, direction indicator, and coordinate system, author. Besides, we also provide a complementary document which records the coordinate system information. Now let's back to the SuperMap Desktop X software and close this map window. Then the first step is to new a layout. In Workspace Manager, we can find the Layout node, right-click on it, and New Layout. Here we choose a blank layout. And this is the layout window. For this layout, we can change the orientation, size, and margins of the page. For example, we can change the orientation to landscape and set the size to A4. And the second step is to add a map body into this layout. Under Object Operations tab, we can see the Objects Drawing group. And in Maps drop-down list, we can see the different shapes of map body: rectangle, round rectangle, polygon, ellipse, oblique ellipse, and circle. This time we choose rectangle and draw a rectangle in this layout. After drawing, this system will ask you which map would you like to put in this map body. Here we choose Precipitation Map and click OK. At this time, if we try to scroll, we can only zoom in or zoom out the layout. The map shown in this map body is actually fixed. So to adjust this map, we need to click Layouts tab, and in Map Operation group, click this Focus Map function. And then to choose a tool to adjust this map. Here, I scroll in to make this map smaller, and then to pan to put this map into the middle, and click Focus Map again to make this map fixed. Then adjust the map body. Okay. This is the main part of this layout, the map body. And the third step is to add some complementary elements to this layout to enrich the elements. First, we can add a title to this map. Under Objects Operations tab and in Objects Drawing groups, we can see there is a text function. Click on it and to add a title to this layout. Annual precipitation in southeast region of Brazil. Then right-click on it and put this title into the middle. And then select this title and right-click on it, open its properties. In its Properties panel, we can change the font to Andorra and change the font size to 30 to make it bigger. Change the font size to 26. And besides the title, we can also add a legend to this layout. But remember that legend button is only active when a valid map object is selected in Layout window. So we have to select this map first, and then under Object Operation tab, Objects Drawing group, to find the legend function, we click the legend and to draw a rectangle. Then we have to choose the layer which we want to add the legend. Here we choose Weather Station and Brazil Southeast and click OK. Then in the Legend Property panel, we can change the legend columns to 1 and adjust its shape. We can also change the legend region style, change it to rectangle. And if we find the text is too long, we can change it in our map. Double-click on Precipitation Map and open it. Then, for the Layer Manager, we can change the name of Weather Station Southeast layer. Change it to Weather Station. And change the Brazil Southeast layer's name to State Boundary. And we save this map again. And back to the layout. We can see the text is updated. Besides, we can add another legend. Also draw a rectangle. And for this legend, we only want to show the legend for precipitation. And then to change the legend columns to 1 and adjust it. Change its legend region style to rectangle. And for this legend, we can change its name to annual precipitation. Okay, that's all about these two legends. And then we can also add the scale and the north arrow to this map. And remember that the scale and the north arrow buttons are only active when this map object is selected in this layout window. Here we choose the scale and to draw it. For this scale, we can change its major scale value to 200 kilometers. And use the same methods to add a north arrow. And at last, if we want to add more information about this map, like the coordinate system and the author, we can also add a text to this layout. In the data folder, we can find a txt document. Open it, we can see the information about this map. Copy it and add text to this layout. For this text, we can change the font size to 15 and drag it to an appropriate position. Okay, that's all about this layout. Finally, we need to save this layout. Right-click in this layout window and save layout. Here set the name as precipitation layout. And click OK. Then we can see this layout under Layout node. If we want to export this layout, we can change to Layout tab and export this layout to picture or PDF. Take picture as an example. When I click this button, we can open this panel. And to set the file name and its saving routes. Here, we can also change the resolution. If we want to export a clearer layout, we can set the resolution to 200 and click OK. Then we can find the layout picture under this route. At last, here is some notice for you to submit your works or get technical support. Our official website for the 22nd SuperMap GIS context is shown here. You can get some official information on it. Remember that your deadline for submitting your works is November the 15th. And when you submit your works, please compress works into zip files and name it with your name and category. All the submission emails are shown as below. That's all about today's lesson. Thank you, and let us know if you have any questions.